All right, I'm Steve Loesch, been a DBA for 37 years. I've worked at Platinum and CA and several other companies, always as a DB2 DBA. Oh, wow. Okay, there we go. So here's our agenda. The main topic is do-it-yourself DB2 solutions. And I'm going to specifically talk about automating a DB2 utility, that stabilized access path for dynamic SQL statements, some fancy SQL against the catalog, and how I've added some new DB2 version 13 features to the system. Okay, and I moved from Chicago to Pensacola 6.5 years ago. So this is our favorite pastime in Pensacola, watching the Blue Angels. Now, all the great pictures are from Wednesday, their practice. And the Pensacola, that's from 3 years ago in July. Here's our Navy Federal disclaimer. Whatever I say is whatever I say. Navy Federal is the largest credit union in the U.S. and they're based in Virginia, and this picture is our campus in Pensacola, and we service all the military services, and there's 14.6 million members currently. All right. Working on. So normally I've talked about DB2 version 13 or 12 features, but this time I'm going to try to explain how I've created my own solution in ISPF. Only with IBM, no other tools, only IBM solutions. So it's either SQL, or right here we go. Using ISPF panels, Rex, DB2 SQL, custom native functions or procedures. So a lot of the solutions are actually stored in the catalog as functions and procedures. And the functions and procedures call IBM provided procedures. So the whole solution is within IBM technology. And over the years, I've worked with, I think, every vendor's products. So, and please ask questions anytime you want, in case it gets a little confusing. So this is a basic panel design that the system handles, and it's all under ISPF. Each screen would bring back a part of the catalog, database, table space, tables, profiles. I'm pretty sure it's almost every table. Where it's light blue, as a column, you could sort the column, hit the refresh button, switch to any DB2 that LPAR can connect to. All right, and the major components of ISPF are displaying the panel, file tailoring services, which generally means you can use variables to create a file or JCL. All right, and there's a test facility. All right. Now the main trick over the last 10 years, I worked on this system over 10 years, and before there was dialog tag language, you'd have to code the ISPF panel the hard way, let's say that. So this screen here is showing the dialog tag language right here, and then what the panel would look like when it was all actually running. Okay, and the tag language is kind of like HTML in a way. You have regions, areas, you can define a row, and all the columns in a row, and it'll automatically space things out. So once you've developed your tag language, then there's a component called the dialog tag language converter, which is pretty much like a Rex exec or CList. I'm not exactly sure internally what it is, but that's the name up here. And you'd run that against your source, and then it would generate this. So you got to decide, do I want to code this as a panel or this as a panel? Either way will work, but the tag language is more consistent once you get used to it. Yeah. So how many people are just DBAs and also want to be a programmer or were a programmer. How many were a programmer before? Okay. So then you might have the ability to build your own system if you wanted to.
And I usually encounter this version rather than
Yeah.
the other version.
Yeah, this is not known unless you really dig into it,
Yeah.
that you can do this.
So that's like, oh, I didn't realize that was available.
Yeah.
Yeah.
Yeah, and then you compile it or convert it, and then you have your regular panel.
Wow.
So it's, you do this step, you kind of design your panel and then work on the logic. That's how I do it. Okay, and then if I'm, say, my main example is like the database table, very simple table. So you want to build SQL against the database, sys database, and is there any where clauses you want to deal with? You have to fetch the rows back from the catalog, and then you have a display loop, and then there may be functions that you could perform on each line, like display all the table spaces in the databases, display all the tables, do a run stat against the database. Okay. And yeah, this is just saying that these are the steps I would do to build SQL, have some code to develop a where clause. Usually there's like, equal, greater than, less than, sometimes between. And I always let ISPF do the sorting. That's just internal code in the recs. So I don't have to worry about DBT wasting time sorting. There's variables and whatnot to handle sorting on any particular panel. All right.
So no order buys in your selects.
Correct, no order buys in the select, just with UR generally 99% of the time. And if I limit the rows, I just stop fetching after so many rows, or I'll embed the fetch first so many rows in there.
Okay.
All right, now, and this is just one routine. I made it fit. So up here we're doing a where clause. Whether we want the like or an equal, and the other trick that almost, I like to code asterisk instead of percent sign, so I convert the asterisk to the percent sign in the code a lot. And then the trick at the end is you have your SQL statement and you just embed the filters in the right place in the SQL. And the other cool thing I did over the years was develop a fetch routine, because it gets kind of ugly. This table has 12 columns, this table has 13 columns, and then this one routine will generically fetch any combination. Okay, you're passing in how many columns you want, an abbreviation of the internal ISPF table. So when you display a panel, you're giving it a ISPF table name to display, which is, I don't want to go backwards, but it would be all the columns that you wanted to display in the database table. All right. There's 80 screens, so I'm going a little quick. Or there's 80, I have 80 slides. So this part I did new. So if there's any questions, let me know if I'm not making sense. All right. So this is some more source code where I'm showing the loop that you want to loop your display of your panel until you perform a function or you hit PF3 to get out. All right. All right, now this is discussing the other major concept is if I'm writing procedures or functions, mostly procedures, it's kind of like mentally a wrapper around the IBM procedures. And the main procedures I've used over the years is getting the zparms, refreshing a WLM environment, running utilities, running a DB2 command. You can create, write PDS, data sets and PDS members, and you can also develop job processing, submitting a job, waiting for it to end, bringing back the output, things like that. So I've used all these features over the years. All right, and then, okay, this is just discussing native functions and procedures. So for functions, did some conversions, string conversions or number conversions. as functions, some word wrapping functions for different procedures that I wanted to write. Here's some major topics of native procedures that I've written. Generating DDL. So the cool part about SQL is everything's in the catalog, so I've developed a procedure that generates the DDL out of the catalog. And it's very accurate. And the one I'll be discussing more today is generating utility templates. So I handle all the utilities except for recover. That's just too paranoid to want to automate that and let somebody submit that at will. Let's see. I was at a company where they had a lot of project type native procedures, so I developed a system to promote the procedures to different DB2 systems. And part of that system was also to archive the routine, because I didn't trust the developers to save their code. So they said, oh, I want the old one back. So I'm like, okay, well, it's saved in the archive. Develop some procedures to compare the catalog, so connect to another system and see if there's missing columns or indexes or RI. I have a whole system for the dynamic statement cache, managing that. I don't think I've seen a vendor tool manage the statement cache yet. A generic error log routine, so the developers could use that routine. Anybody could use a routine who wanted to write an error message. And here we go. Running IBM utilities, and you could either store the output in a DB2 table or just run it through JCL. All right, next section. I'm going to discuss one of the utilities, okay? If I discuss them all, we'd be here for a long time. So, all right. The main benefits of utilities is I'm sick of copying PDS members. I just want a consistent way. So if I do in the procedure, it handles load, unload, reorg, run stats, rebuild, copy, modify, check data. So once you have all that working and in your shop, you have your standards, your sizes, then you don't have to keep coding it over and over again. All right. And the other major trick on this is I save the output in a DB2 table if you don't want to run JCL. So the system, so you can run utilities with 0 JCL. Now, how do you accomplish that? You got to back up a little, and you got to have some of the IBM tools installed first before you can do some things on your own. You have to have a WLM environment for the utilities to run in. You could develop a sample PDS member of templates that you could add to the WLM environment. And you have to develop your own native procedure to actually generate the templates. All right. And in this case, when you're automating the utilities, you have to have enough of these DD statements to add to the WLM environment. You have to install the util-u, which is in the JRT job. And you have to have the right security to actually execute the procedure. And if you're managing your environment, you have to know how to refresh the WLM environments in case they get stopped. If something bad happens, it gets an 04E or something, it'll stop the started task and you have to refresh it. Here's sample JCL for the started task. In the notes of this PowerPoint, I have various instructions on where to find things. Okay, so yeah, I'm going to walk through unload. every utility works, but this is unload.
So this is a screen that you made?
Yes.
Okay.
Right, so you were like on a table and say, I want to unload it, so you press UL, press enter, and then this screen pops up. All right. So if you use option 1, you can see the template of the syntax to unload a table. First, and then when you selected a table, it would automatically fill in the database and table name and your database ID and today's date as a temporary file name. And it can handle load, comma delimited, or EBCDIC. It depends on how many shops are messing around with Unicode versus EBCDIC. And you could add a when statement for the unload. All right, I could talk about all the options. So if everything looked right, you could just hit option 3 and run it, submit it as a job. Or if the table wasn't very big, you could use option 4 and it'll just do it right there in your TSO session. Yeah. And number 6 would let you look at the JCL before you submit the job. And number 7 would make it like a regular DSNU proc, nothing fancy, just a regular job with the template in there. Yeah, so we're going to show that now. There's a generated template. Here, this is the table layout for storing the data if you want to do it that way. All right. Okay, and here's a sample. This is a sample screen. This would come back if you do online unload. Comes back. You could do 100,000 rows in like 2-3 seconds. Comes back quick all the time. If this is the JCL to run it, you wouldn't be running it online. You would be running it here in batch mode. But this is the input. And the input to the procedure is HTML type syntax, so I can have as many variables as I want. And this is just regular JCL with the template in there. So if you didn't want to do anything extra, this is just a regular job for the unload. Pretty good. And this is the screen that stores the output. This is how you could retrieve it for later on. Some people would say, why do you want to do this? I don't know, because you can. I mean, the one cool feature is if you had a lot of test systems and you did things different ways, it actually stores a template in there too, so you could, see where is it? Here's a sample output. It just comes back as a file name, temporary file name, if you want to look at the output. And here's the options. You could see a short message, see the whole file, or it would bring back a job you could submit. So SJ, I just made that, so it would show the template in a new job. So you could run it again later. Okay, pause now. Any questions on what we've had so far?
I have a question.
Yes, sir.
How many other people, or are there other people at maybe Federal Credit Union that help you with this, support it?
I've had this written for a long time, so there are a few people who have helped do some new things.
Okay.
But yeah, this has been working since my other prior job in over 10 years ago.
Okay, very impressive.
Yeah. So
So what we're trying to do now, see, because I worked at Platinum, I tested all the tools, and I worked at CA, and they had, my favorite story is they had horrible operations. So if I submitted a reorg JCL at Saturday at 9 o'clock at night, well, the job didn't work. Thank you very much. That's all the help they would give you. So we got a system that was able to do the reorgs without JCL. So all we had to do is look at the table and say, yeah, everything's working out, everything got to return to 0. Well, that's the main reason it was invented. Okay, so now this this is the store procedure that would generate templates. It's 3,000 lines long, but we're not gonna look at 3,000 lines. We're just gonna kind of highlight the part that would get you through the unload, okay? So, let's stop here. So as you can see, input to the procedure is just one parameter, one XML parameter. I learned this trick back in 2010. So instead of having 40 parameters, you just have one. So the first part of the procedure is to turn that XML in parm, over right here, in parm, into variables. So it would decipher, and whichever variables were not null would then have a valid value. And in the rest of the procedure, you could then use the P1 variables as input to getting data out of the catalog to figure out which table space it was, things like that. So the main trick is then to use common table expressions to build as many of these as you need to get the data out of the catalog as the next step.
Wow.
Okay? So that's the other reason I'm doing this. How do you develop your own procedure? And it's very similar ideas with generating DDL.
Wow.
You get the data out of the catalog, and then you create statements. Okay, so this next one is the unload, whatever columns I need for the unload, and then the next one is the list of columns that are going to be unloaded. So you have all these CTs, 5, 6 different parts. Now you then have to put them together in the statements, and the trick there is just do union alls and add an integer number to get the statements in the right order.
Right.
That's the trick.
And is this, you said that, like, you were saying that, like, some tables had 10 rows or 10 columns, some had 11, some had 12, and that this would handle that?
Yeah, that CTE columns would have as many rows in it as columns in the table.
Okay.
Okay. And when I was talking before, that was fetching columns out of a generic, out of a catalog table. This is fetching columns, a list of column names that you're going to unload from table X. And the other cool trick that's in here is when you unload, the large objects have to be at the end, not where they were defined. So it handles that too. But we're not going to discuss how you can see that later. So then here, you're putting the statements together in the right order. Okay, and the other cool trick about it, once you learn a lot about XML, we used XML to build the variables. Now we used XML to turn all the statements into one varchar column, one varchar variable. That's what this last part does. You wind up with XML ag, and you're outputting the statement, because the input to util_u is a couple parameters and just one varchar of the template. That's how util_u works. Okay. So that's how that
magic.
works.
Yeah.
So that's all new,
Wow.
but there's a lot. I mean, it just gives you an idea of what can be done. All right. Now the rest of this I've kind of presented before. So you have a column, so you could have a panel on every DB2 catalog column, but now in this case, dynamic SQL statements is a whole nother animal. I don't know, does anybody use that feature, capturing the SQL and storing it in the catalog? Still nobody, huh?
We
extract the dynamic SQL
statement cache, and
Yeah.
we store it in.
Excel spreadsheets.
Okay,
Yeah, so we do our.
that's one way to manage them, but this idea would actually store, I'll show you more specifically, but you could actually store dynamic statements in the catalog,
Oh.
in the sysdyn query, SY, yeah. System query catalog tables. And what that gives you is the ability to store it there, the access path is captured. So when you're bringing different data sharing members up and down and they rerun their SQL, it's already captured.
Yeah. Yeah.
And the other major benefit I like is that I could, if I want to look at a table or a view, I could see what packages the table's in, and now I can see which dynamic statements are used by that table. So it's a nice way to audit your system.
Yeah, more meaningful.
Yes. Okay, and this panel is just showing different reasons. When you want to capture SQL, these are the kind of the exceptions that will not be captured. Yeah, it won't capture temporal or transparent archiving SQL yet. And the other major benefit is still, or hindrance that kind of stops most people maybe from using it, is that you can't just rebind. If it becomes inactive because you changed a column in a table or messed around with the table space, it'll inactivate that SQL and you have to recapture it. But you can't rebind. That's the word. Does that make sense? Once it becomes useless to the catalog, you have to capture it again. Okay, and if the way you start analyzing is doing what you were saying, you capture the SQL dynamically or in your own statement cache table, and you analyze it to decide, is there certain user IDs worthy of capturing? With certain user IDs, certain systems will just generate one unique statement, right? 11111. They won't run the same statement 20 times. So you have to analyze your data to decide which user IDs to capture. Okay, and this is a SQL statement that could help with that, showing a group by which user IDs, how many statements are captured, if there's a lot of CPU time associated or elapsed time. Okay, and this is the catalog table names that captures the SQL. Obviously, System query has the SQL statement. The dependency stores the views and table names. I believe indexes also that are dependent on that query. And there's 4 of them that are just internal, and there's no good description on those tables. You can kind of guess by the name what they are.
So are you saving things away on a regular time basis or just at request?
Oh wait, say that again, please.
You know, saving the data away into these tables, are you doing that like on an interval, or are you just doing that whenever you go into the ISPF dialog and request it?
Okay, yeah, after you've looked at the statement cache, you can see which user IDs you want to capture. So you start a capture for that particular ID, and you could let it run for a while, or you could just capture it once, and whichever statements it finds that meets your criteria, it'll pop it right in the catalog in like 2 seconds. Okay, and then you can display. So I'm going to walk through these real quick. Here's your start. What I like to do is break things up by user ID, so my group name is also my user ID. Okay, and then you have a monitor yes or no, and if you say yes, the capture keeps running looking for more statements that will match that user ID. Or if you say no, it'll just capture it once and end the capture. And the scope group will go to all the data sharing members looking in their dynamic cache for new SQL. The display command is real simple. It just tells you how many statements were stabilized or captured into the catalog. And every time you do a new capture, you get a new, I believe CNO stands for capture number. That number just keeps going up and up and up. But it has no real meaning. So if you start a capture, you get a capture number. That's all. It's not anything that important. But every statement that's captured gets a unique statement number. and that number keeps going up too. Okay, and the stop is very simple. It'll just stop the capturing whenever you issue this command. And if a statement becomes invalid or unused, you can free it. Okay, and you free it by statement number. Oh, you can also free by the group name, but that's kind of a rare occurrence. And the statement cache has its own explain syntax. You say explain stabilize dynamic query by statement ID, so one ID at a time.
Okay, so that's,
That right?
that answers my question.
Yes. And that report there is just it's SQL based, and it's an explain report off the explain table. Plan table and the children of the plan table.
We're a little antiquated, we capture the statements and then run an actual explain. Where I guess this is doing it for you.
Yeah.
Yes, it's smarter.
And then this one, I just added this one because the notes in this panel have a description of all the columns. So this is a good one to have notes on. And this is my last iteration of trying to do the report. We're in the middle. In the middle, we have the index names and an asterisk for which columns are actually used. I added that like a couple years ago.
Oh my gosh.
Yeah. So that's all SQL. So I always try to do a solution with only SQL, not needing dependency on COBOL or Rex for the answers. Okay. And then this is a little SQL output of a SQL for showing the dependencies in a dynamic statement. And then this similar report also works against packages. Okay, so once you've captured, you can't just walk away and say you're done, because you have to manage it. And you have to manage, you'd want to manage the unused queries by getting rid of them. And you have to watch that the developers haven't been, messing with the table space or adding columns, which would invalidate some of the SQL. So you need to clean up invalid statements and unused statements. And you just make sure these tables are reorged when you reorg the catalog. I'm sure everybody does that occasionally. This is a SQL statement that will let you look at sysdyn query, so you could see the last used and the valid column in the middle. Right in there. And generally speaking, if things are working right, almost every day or every other day, the last used is the current date. And those are the ones you want to keep. All right, and when you want to free a statement, this is kind of, I do everything with SQL, so if a statement gets old, it hasn't been used in 30 days, it generates a free command, and then in the next step it would execute the free commands in that job. Any questions so far? Am I going too quick? All right, okay, and this is an example of a start command that would recapture if you cleaned up an ID because it had invalid statements or unused statements. This is how you would recapture. Monitor no, you only want to do it once, and use the group command to look at all the different data sharing members. All right. We're doing good. We're doing good. All right, so here's some fancier SQL. So we discussed that you can capture the dynamic cache independently, right, anytime you want, right, and just have it in it's a separate table. And you have system catalog that's now has the captured SQL, well, now you could, if you join those two tables together, you can decide or see how efficient or inefficient that SQL is.
Right.
And that's right here. This panel is too wide, so you can see how many times it was executed. So it's executed a lot, so therefore it was worthy of being captured, right? And when you scroll over, you can see that they're all running very quickly. So there's nothing to really tune on this panel. So if they're running more than whatever minute, seconds you decide, you could do explains and see if there's something wrong, maybe a missing index, or maybe they're just searching too many large tables. But usually they need it, so you can't do much about it unless you can add an index. And these panels are just showing all the columns that you could retrieve, but the panel's only retrieving a handful of important columns. And these are all the different commands you could do against one statement, which I've already discussed. You know, capture, display, free. You could free one. You could, on this panel, you could free a statement one at a time if you want, or just go look at the SQL. Hit Q and go look at the SQL. All right, now, before this came along, the dynamic SQL capture came along, this SQL would, right here, could join a table, two packages, and you could see where a table, which packages a table was in. So then I add one more union all, and now I can see which dynamic statements are used by the table. And that panel looks like this. You have table names and view names. And if you have a package name, it just has one line or one name, the owner. Yeah, the owner and the package name. Or if it's dynamic, I showed the group and the SQL ID and the statement number. And from this panel, you could jump to the queries. And we call this the CRUD matrix, or I call it where used. So it's create, read, update, delete. So the CRUD matrix, and then the columns on the side show you if it was a create. So if you have dynamic SQL, you can see is it just selecting with R for read or C for create, and then update, delete. And you can see the last time it was used. And the last use is also based on the package. So you can see which SQL is actually being used every day.
Oh, so you're combining the dynamic and the static.
Yes.
Yeah, awesome.
Yeah.
Very nice.
Uh-huh.
Oh, brilliant. You're brilliant. You are
Just
so
one step at a
brilliant.
time. You just do one little block at a time. You know.
Brilliant.
Yeah, I used to wonder why Detector was bringing out the system, and I was always thinking it was IBM. I'm like, wait a minute, I work for a vendor. It's got to be Detector. What am I looking at? Yeah. Okay. All right. So now, a lot of that stuff already existed for a while. So now version 13 comes along. So then you start thinking, what can I add to my system to handle version 13 ideas? Because there wasn't that much SQL, or new columns and whatnot. So from version 12, we had fast index traversal, and they've added some features, right? Every index type, whether it's primary or unique or duplicate, and the length got bigger. So I had to modify the panel to handle the situations. And the black screen there is just what you get if you do a display command. Not very helpful. And the bigger panel is what you could do by yourself. list the table name, the index name, and whether it was unique or primary index, and how much memory is being used, and the length of the key. And then you can make a jump to the index of the table from that panel. So it makes things more useful. Okay, and then regarding index space, index splits, there's there's new columns in version 13. And we did have some split issues where things were slower on a table that was being hammered all the time. And I guessed where it was, and then this statement, or this SQL proved that I was kind of correct. So the splits column that means there's more than 1 second used to split an index, okay? So the ones with the higher numbers are the ones potentially causing trouble. So if that was consistently a high number, you might want to maybe rebuild or maybe organize that index key in a different way. Okay, group buffer pool residency time. How many people are in 13? Enough, yeah. So if you have the right configuration, ZOS 2.4 or better, a Z16 or better, and level 25 in the coupling facility, and provide the answer, the data by 1 million, so you could see it in seconds, so it makes more sense. And then I added it to one of the panels so I could see the residency time on my group buffer pools. And 0 means that there's no issues, that that data is not being circulated enough or at all. And then if you have a number, that's how long it's lasting before the data is kicked out. And this is group buffer pools, not regular buffer pools. We made it. 45 minutes, wow. Okay, any questions? You want me to talk about buffer pool tuning? No, I mean, is that your question? Okay, I have a different panel for buffer pool tuning, but if you were buffer pool tuning, you'd want to, well, yes, if these numbers were low enough, you could add more buffers. That's the main clue. But you also may have to make the local buffer pools bigger too, if you want to have more residency time. Is that what you're asking? Yeah. Or move them around. Like we've recently done a check, and I found some tables that I could maybe move to a different buffer pool where they are more sequential. So then the ones I moved them from would be more random, so that would help the two buffer pools be more stable, or at least help the random one be a lot more stable. All right. So I hope I gave you how to do, not kind of how to do things, or what you have to, here's what you have to know. Here's what you could research on how to do things. Dialog tag, dialog developer, Rex. And the one for the IBM stored procedures, that call and beyond, that gives you a lot of clues on how to use the IBM procedures. Okay. Thank you for your time.